Well, hello everyone. Today I wanted to take a couple of problems from our last concept builder, Force and Motion, and kind of look at it a little bit and then tweak it so that we could see if we could learn about the direction of the force and the resulting acceleration. So kind of take a little vector turn at this. So here is one like you might have seen in the concept builder. All right, we've got a force diagram right here of an object. And then here are choices for dot diagrams that could represent the possible state of the motion. And we want to find one or two or three or however many we need that actually represent the motion, or could represent the motion with this force diagram. Now, one of the key things that sometimes people have trouble with here are these arrows. These arrows are directional arrows. Okay, so the three up here are dot diagrams for an object moving to the right. The three on the bottom are dot diagrams for an object moving to the left. So that's super important. Right? So with this force diagram, now notice, are the forces balanced? No. Right? This is obviously an unbalanced force. There's nothing over here to balance it out. The vertical ones are balanced, but the horizontal one is not. So when it's moving to the right, which of these fit this diagram? Well, this first one, it looks like it's moving constantly. Well, that's not it, because it's an unbalanced force. The middle one, it's speeding up because the dots are getting further apart. And the last one, it's slowing down. So given that it's moving to the right, and this arrow's pointing to the right, what do you think? Yeah, it's going to be that one right there, right? That's going to work. What if it's going to the left? Here we have it moving to the left constantly. Not going to work because it's an unbalanced force. Here it's moving to the left and slowing down, and here it's moving to the left and speeding up. Well, look at our unbalanced force. Right? It's working against the motion. If it's moving to the left, this force is pushing against it, so what's that going to do? Yeah, it's going to slow it down. Okay with that one? So it could be moving to the right and speeding up. It could be moving to the left and slowing down. And we can't tell just from the force diagram. Right? Without some extra information, we can't tell which one it's going to be. Okay. Now that's what you had to do in the actual concept builder. But I want to add in a little thing now. So look at the force diagram. What's the direction of the net force? Well, it's to the right, right? Because this force is out here all unbalanced. But here's the key question: what's the direction of the resulting acceleration? Well, let's take a look at the top one. It's moving to the right and speeding up. So let's think about the rules that we know, right, for acceleration. And remember that the vector nature of acceleration is fairly complex. Right? We did learn a little thing that we saw in our speeding up and slowing down activity last unit, which is that if the object is speeding up, the acceleration has to be pointing in the same direction it's moving. And if it's slowing down, the acceleration points in the opposite direction it's moving, right? Works against it, if you will. So in this case, it's speeding up, so the acceleration has to be in the same direction it's moving. Down here, it's slowing down, so the acceleration has to be opposite the direction it's moving, but look what that is. It's moving to the left, so the acceleration would be to the right. In both cases, the acceleration is pointing to the right. And the net force that caused that acceleration is also to the right. Coincidence? Well, let's try another one and see. Here's a vertical problem. Now you'll notice in our force diagram we only have two forces. They're both acting vertically. So maybe this is like an elevator or something like that. But notice that the upward force is bigger than the downward force. Right? Upward force is bigger than the downward force. So again, the forces aren't balanced. So right away we can get rid of these three over here because those are all constant velocities. Right? So not moving. Balanced forces. So it's got to be two of these four, right? So let's look at these two. Here we have it going up and speeding up. Here we have it going up and slowing down. Well, which one's going to be if it's this way? Well, yeah, since the upward force is bigger, right, it's going to go up and speed up. What about if it's going down? Would it go down and slow down, or would it go down and speed up? Well, again, net force is up, So if it was going down, that works against the motion, and so it would slow down. Right? So there's our two answers. It could be going up and speeding up, or it could be going down and slowing down. The net force, though, is always up, because this force is always bigger than that one. But what about the acceleration? Here it's going up, right? Arrow's pointing upward. So it's going upward and speeding up. So that means the acceleration has to be in the same direction, right? Which is upward. Here it's going down and slowing down. So the acceleration has to be in the opposite direction, which is also up. Oh, look at that again. The acceleration, no matter which one it actually is doing, the acceleration is always the same direction, in this case up, which is the same direction as the net force. See the pattern? So if I were to give you a net force, we could then infer the direction of the acceleration and vice versa, because they're always in the same direction. Hopefully this kind of makes sense, right? I mean, if you push on something, it accelerates, it speeds up in the direction you're pushing on it, right? If we can neglect frictional effects here, right? And that's all that this is really saying, right? It's just saying that whatever direction the net force is, that's the direction the acceleration is going to be. Now, what that means to the object depends on which direction it's moving, which was the whole point of this concept builder, was to show you that it could be speeding up in one direction or slowing down in the other direction with the same net force and acceleration. Right? But it does show you that acceleration and net force are always in the same direction.